Section 4.5, graphs of sine and cosine functions. So we're going to look at understanding the graph of our y equals sine of x, graphing our variations of y is equal to sine x, understand the graph of y equals cosine x, graphing variations of y equals cosine x, using vertical shifts of sine and cosine curves, and model periodic behavior. So hopefully you have some sort of basic understanding as to what happens with our sine function. There's a little demonstration I want to share with you that looking at the unit circle, if you can kind of see in the middle of the screen there, as that green dot is going to travel around the unit circle, it's going to map out what happens with our sine function. Now, if you remember, sine is our y value. So as that point travels around that circle, it maps out how high it goes and then how low it goes. And in this case, we're going to have a radius of 1 unit. So that can continue on past one time around the circle, and it's going to continue on. It's going to keep going. So what happens with our sine function is as that circle goes up and around that unit circle, as that dot goes around the circle, right, we're able to see the highest it hits and the lowest it hits, right? If I go all the way back to the very, very, very beginning, right? As that point goes around the circle, the highest point that it hits, if it has a radius of 1, is going to be to 1. Now that's at our pi over 2. As we continue around the circle, once we hit pi, it's back at 0. As we continue on, we get to our 3 pi over 2. It's down at -1. And as we get all the way back around the circle, I went a little too far. Pretty close to around the circle, it's going to hit back at that 0 point again. And as that sine function continues on, that can go on to infinity. It can continue going as many times as it wants all the way off of that right-hand side of our graph. And it could have also done the negative. It could have gone to our negative degree or negative angle around that circle. So just a little representation as to what's going on with our sine function. Some things that you would have learned in your trig class last year. But it says the sine of y is equal to, or the graph of y is equal to sine x. When x is equal to 0, we have y equals sine of x. That's at 0. That's at our starting point, assuming that we've had no other changes to our graph. And as it progresses around, so we have the starting point at 0. So we are at 0. As it gets to that pi over 2, that is when we are at the peak, at the maximum point that we're going to hit on our graph when we have a radius of 1 unit. And then it's going to continue to pi, which is going to get back to 0. It's going to get to that 3 pi over 2, which is going to be our least value, the lowest point that we're going to end up hitting on that graph. And then it's going to get all the way around back to 2 pi or back to 0 again. So our graph is kind of broken into, there's 5 main points that we're going to look at, but it kind of breaks it into 4 sections. So if we take a look at some properties of our graph of y is equal to sine of x, it says that the domain is negative infinity to positive infinity. We can go as far to the right and far to the left on our graph as we want. There's no limitation on what we put in for x. There is a limitation with our range. Now that's assuming that we have a radius of 1, then our range is going to go from -1 to +1. The period is 2 pi. As in all sine functions. And it says that the function is an odd function, meaning sine of negative x is equal to the opposite of sine x, what we talked about previously, right? And so we see our graph. So what happens is we're going to start at 0 and we're going to go through 1 period, right? This says 1 cycle, which our period is 2 pi. So we're going to go up to the peak. We're going to go back down to 0. We're going to go to our minimum value, and then getting back to that 0 point. Now, if we needed more than 1 cycle, that's when it's going to continue on into another cycle and another cycle until it tells you to stop. So graphing variations of y is equal to sine x. Now I have a little blurb kind of put in here. All the different transformations, what happens when you transform that function. So it might not be a bad idea to pause the video and kind of write some of that stuff down, because as we continue on, we're going to be building onto our basic sine function, and hopefully you remember some of this from last year. So number 1 says to identify the amplitude and the period. Now your amplitude is going to come from that a value that's in the front. That's something that's being multiplied with your sine function. So as I said, you're looking at the absolute value of the amplitude, meaning the number, not caring if it's a positive or negative, just the number itself when it talks about an absolute value of it. That's going to tell us if we have some sort of vertical stretch or shrink. That means it's going to get really, really tall or it's going to get really, really short in terms of looking up and down. Inside those parentheses, we have a bx minus c, and we're going to eventually, not right this second, but talk about a phase shift. That's where you take that centerpiece, you set it equal to 0, and then that's going to tell you how that's going to end up shifting. So the starting point at 0 occurs on your typical sine function, but it could end up shifting left or right depending on a phase shift. Now our period of our sine function is a 2 pi. Sometimes that changes depending on the b value in front of that x. And then the last piece is talking about a vertical translation. Now I'm kind of getting ahead of myself before we talk about all these key points and getting into some of these graphs. But I think once you see the initial setup, it looks very similar to all of our function transformations that we've done in previous chapters. So step 1, we kind of talked about. Step number 2, it says to find the values of x for the 5 key points. If you remember, I referred to those 5 key points. It breaks it into the 4 sections of our sine function. It says the 3 x-intercepts, the maximum point, and the minimum point. So how do we find these? It says to start with the value of x where the cycle begins, which typically it's at 0 unless there is a phase shift. And add quarter periods. So if you remember, we're taking our function and we're breaking it into 4 parts. So you take your period, which typically is a 2 pi, and you divide it by 4. But if something happens that we don't have, we have that b value, that can end up changing out what that number looks like. So we're going to take the period, divide by 4 to find successive values of x. Step number 3, we're going to find the values of y for those 5 key points by evaluating the function at each value from x from step 2. And then we're going to connect the 5 key points with a smooth curve and graph 1 complete cycle of the given function. And step 5 says to extend the graph in step 4 to the left or right as desired. So they will typically tell you how much of that graph they want to see. Sometimes it's just 1 period or 1 cycle. Sometimes they ask for more than that. So let's take a look at our basic function, right? Graphing a variation of y is equal to sine x. It says to determine the amplitude of, we have an equation y is equal to 3 sine x. It says then graph y equals sine of x and y equals 3 sine x for, we're going to go from negative pi is less than or equal to x, which is less than or equal to 2 pi. So we're going to go through those 5 steps. Step number 1, we need to identify the amplitude. The amplitude is going to be the number that is being multiplied with our sine function. So in our y equals 3 sine of x, that means we're going to look at that number 3. So we have a is equal to 3. Thus the amplitude is, if we take the absolute value of that, the absolute value of 3, we're going to just end up with a 3. So our amplitude is going to be 3, because remember we had to take that absolute value. It says this means that the maximum value of y is going to be, well, 3 above. The x-axis would end up being 3. And the minimum value of y is going to be 3 below the x-axis, which would end up being negative 3. Now, in terms of the period, there is no change to what's going on with x. So that means our period is just going to end up being a 2 pi, as all sine functions are. Step number 2, it says to find the values of x for those 5 key points. So to generate x values for each of the 5 key points, we begin by dividing the period, which is 2 pi, by 4. And the cycle begins at 0. It begins at 0 because we had no phase shift. So that means we have our x1 value is going to be 0. So it says we add quarter periods to generate x values for each of the key points. So we take our 2 pi and divide by 4. 2 pi divided by 4 means that we are going to have increments of pi over 2. That means I'm going to take whatever I start with my 0, and then I'm going to start with 0, and I'm going to add a pi over 2 to figure out what my x2 value is. So 0 plus pi over 2 is going to give us a pi over 2. To find our x3, I kind of had an oops here. I don't know if I fixed it on your notes. So we're going to start with whatever we had from x2, and then we're going to add that pi over 2. Well, pi over 2 plus pi over 2 gives us pi. For x4, we're going to take pi and add a pi over 2. So that's going to end up giving us a 3 pi over 2. For x5, we start with that 3 pi over 2, and we add another pi over 2, which would give us 4 pi over 2, which is going to end up being a 2 pi. Step number 3. It says to find the values of y for those 5 key points. So these 5 key points are what we just found out in that last slide, or that last piece in step 2. So now we just need to evaluate. If I take 3 times the sine of 0, well, sine of 0, sine is my y value, and if I'm at 0, that means I have a y value of 0. So 3 times 0 is going to give us 0. So we're going to have the ordered pair 0, 0. If I have 3 sine of pi over 2, well, pi over 2, the y value is going to be 1. So 3 times 1 gives us 3. So when we're at pi over 2, we're at 3. If I have 3 sine of pi, when we're at pi, that means we're back at 0. So 3 times 0 gives us 0. So we're going to have pi, 0. Our 3 pi over 2, so that's going to end up giving us -1 for our y value. So 3 times -1 is going to give us a -3. So when we're at 3 pi over 2, we're at -3. And then y is equal to 3 sine of 2 pi. 2 pi means that we're going to be back at 0 again. So 3 times 0 gives us 0. So when we're at 2 pi, we are at 0. So we found all of our points that we need to take it to a graph and to map that out. So graphing a variation, right, we have our 3 sine of pi. Our original y equals sine of x is going to be this kind of black line that's kind of drawn in here. It gets up to that value of 1. It goes down to that value of -1. Now what happens when we had our 3, when we are at pi over 2, we're now at a 3. When we are at pi, we are at 0. When we are at 3 pi over 2, we are at -3. And then when we were at 2 pi, we were back at 0 again. So we're going to have a graph that is going to have a vertical stretch. It's going to be taller than that initial. Now this one said it wanted from -pi to 2 pi. And the graph that's drawn here only shows from 0 to 2 pi. So technically we'd have to extend this out a little bit and give another half of a cycle. So that means I would have needed to, if I had a -pi over 2 and then a -pi, I would have had another piece that would have gone down to -3 and then back up again to show that full amount that they were asking for. And if you wanted the other one in there too, the original sine function would look like that. So let's talk about our amplitudes and our periods. What happens when we start changing some of that up? So it says the graph of y is equal to a sine of bx, where b is greater than 0, has an amplitude of the absolute value of a, and the period is a 2 pi over b. So they show you the amplitude, again, is showing you the distance, right? How much we're going from our x-axis to the least value and to the greatest value in terms of the height of that sine function. And then the period is how long it takes to get through that one full cycle, meaning that we're going to end up going up, coming back to 0, going back down, and coming back to that starting point. That is what one full period is. Now, typically on a sine function, we have our 2 pi is the period, but if that gets changed up by anything, that b value, what's being multiplied by x, is what's going to end up changing what that period looks like. So we have to do a little division there. So let's take a look at an example. If we have y is equal to 2 sine of 1/2 x, it says to identify the amplitude is going to be that number that's in the front. So we take the absolute value of that a value, so the absolute value of 2 is 2. The period is 2 pi divided by b. Now this 1/2 is our b value. So if we take a 2 pi and we divide that by 1/2, well, that's going to end up giving us 4 pi. So the maximum value of y is going to be 2, and the minimum value is going to be -2, because that's how high and how low it's going to go. And then the period is going to be stretched out to 4 pi. So the period of 4 pi tells us that the graph completes one cycle from 0 to that 4 pi. So going up, back down to 0, going down to the minimum, and then coming back up. So step number 2, find the values of x for those 5 key points. So again, we find that by taking the period and dividing it by 4. So if we take our 4 pi and divide it by 4, we're going to go by increments of pi. So our starting point, we still have not changed from 0. So our starting point is still going to be 0, and then we're going to add multiples of pi. So 0 plus pi is going to give us pi. Pi plus pi gives us 2 pi. 2 pi plus pi gives us 3 pi. And 3 pi plus pi gives us 4 pi. So we have our 5 key points that we then go and evaluate. So again, plug some things in. So if I were to have 2 sine of 1/2 times 0, well, 1/2 times 0 means that we have 0. And the sine of 0 is 0. So that means I have a 2 times a 0, which gives us 0. We're still starting at that origin, 0, 0. Now, if I take the 1/2 of pi, that means that we're looking at pi over 2. So sine of pi over 2 is going to give us 1. So 2 times 1 gives us 2. So when we're at pi, we're up at 2. If I take 1/2 times 2 pi, well, 1/2 times 2 just gives us 1. So sine of pi gives us a value of 0. So 2 times 0 is going to equal 0. So at 2 pi, we're at 0. If If I take the 1/2 times 3 pi, that means we have our 3 pi over 2. Sine of 3 pi over 2 gives us a -1. So 2 times a -1 is going to give us a -2. So when we're at 3 pi, we're at -2. And 1/2 of 4 pi, that's going to give us 2 pi. Sine of 2 pi takes us back to 0. If I take a 2 times 0, we're still going to be at 0. So that means we're going to have a 4 pi at 0. Now, maybe you can kind of see some relationships between here, right? 0, there's our maximum. 0, there's our minimum. 0. Kind of makes sense, right? Once you find out what that 0 pi, 2 pi, 3 pi, 4 pi are, once you find out those increments, the rest of the y values should be pretty self-explanatory. All right, so determining the amplitude, right? We took care of that. Where are we at? Step 4, connecting the 5 key points with a smooth curve and graph one complete cycle of the function. So saved you a little bit of time, right? We're at 0, 0. When we were over at pi, we were up at 2. When we were at 2 pi, we were at 0. When we were at 3 pi, we're at -2. And when we were at 4 pi, we were back at 0. Now, this one says that we need to go from 0 until 8 pi. So we were able to graph the first cycle, but if we're going to 8 pi, we only got to 4 pi so far. So that's where on the next slide, it kind of doubles till we get to that 8 pi as our ending point. All right, just shows the same repetition. Just follow that same pattern. Let's try one more part. The graph of y equals sine, or a sine of bx minus c. So this is going to get into what happens when we start having that phase shift. What happens if we don't start at 0? So it says the graph of y is equal to a sine of bx minus c, where b is greater than 0, is obtained by horizontally shifting the graph of y is equal to a sine of bx. So the starting point of the cycle is shifted from x equals 0 to x equals c divided by b. Now, kind of a little hint to that is if you take this bx minus c and you set that equal to the 0, kind of like I showed in that little, hey, jot this down before. If you were to solve that to get x by itself, you would have had bx was equal to c, which means x is equal to c divided by b. So if you ever question, oh wait, how do I find that? Just take that piece, set it equal to 0, and that's going to tell you where that graph is moving. Now, if you remember, inside is opposite of the direction that you think it's going to move. So because we have that minus, right, typically it's going to end up shifting opposite of what you think to the positive. All right, so it says if c divided by b is greater than 0, the shift is to the right. If c divided by b is less than 0, then the shift is to the left. The number c divided by b is the phase shift. It's where that starting point is shifting to. So we still have our amplitude is our absolute value of a. The period is still found by your 2 pi over b. And now we have a new starting point, which is x is equal to c divided by b. So let's try one. So we have y is equal to 3 sine of 2x minus pi over 3. So we're going to graph one period of the function. So step 1 says to identify the amplitude, the period, and the phase shift. So always start by identifying your a, b's, and c's, right? Our a value, the piece in the very front, is our 3. The b value is in front of the x, which is 2. And our c value is this piece that's being subtracted. But we're not going to look at it as a subtraction as a negative. It's just going to be a pi over 3. It's just going to be that positive value. Excuse me. So our amplitude, absolute value of a, our a value is 3. So that means our amplitude is 3. That means the highest it goes to is 3 and the lowest it goes to is -3. The period is 2 pi divided by b. Well, our b value is 2. So if I take a 2 pi and I divide by 2, we end up with a period of pi. So the phase shift is c divided by b. Well, we have a c value of pi divided by 3 that we had to divide by 2. So if we had a pi divided by 3, divided by 2 means we're multiplying by 1/2. So that gives us a pi over 6. So this is going to be the starting point of our graph. That's the start of the graph. It's a phase shift. That means we're shifting from 0, 0 to pi over 6 as that first point on our graph. So that's going to be important with our next piece, which is finding our values, our 5 points, right? Find the values of x. So since our period was pi divided by 4, our x1 value is that starting point. That means our starting point, which is a pi over 6. That's where we're starting from, pi over 6. Now, we had to take that pi over 4 and add it to that pi over 6 to find all of these pieces. So if I take this pi over 6 and I add a pi over 4, that means I need to do a little bit of changing up some denominators, right? Let's have some 12s. That means we have a 2 pi over 12 plus a 3 pi over 12, which is going to give us a 5 pi over 12. X3 is going to start with 5 pi over 12 that I have to add the pi over 4. Well, again, 5 pi over 12, let's make these out of 12s. That's going to be a 3 pi out of 12, which is going to give us an 8 pi out of 12, which simplifies. Divide by 4, what do we have? 2 pi over 3. Start at our 2 pi over 3 and add our pi over 4. That means, again, we're going to those 12s, right? So that means we would have had that 8 pi over 12 added with 3 pi over 12. 8, 9, 10, 11 pi over 12. Starting at our 11 pi over 12, adding in that pi over 4. So our 11 pi over 12 added with our 3 pi over 12 is going to end up giving us 11, 12, 13, 14 pi over 12, which is a 7 pi over 6. So now we have our 1, 2, 3, 4, 5 x values. And then we go and evaluate. So our 5x values are already kind of filled in. It took 2 slides because of the fractions made the formatting a little large, right? So if we were to go and plug this in, there should be kind of a pattern at this point, right? Anyway, if you take this 2 times pi over 6 minus pi over 3, the 2 and the 6 are going to cancel to give you a pi over 3 minus a pi over 3. That means we're taking 3 sine of 0. And if you have sine of 0 is equal to 0. So 3 times 0 gives you 0. So we're going to have a pi over 6, comma, 0. If we were to go and look at the next one, again, we can kind of simplify some things down. That means we have a 5 pi over 6 minus, if these were out of 6s, we'd have a 2 pi. So that means we have 3 sine of 5 minus 2 gives us a 3 pi over 6, which is the same thing as a pi over 2. So sine of pi over 2, which sine of pi over 2 is going to give us 1. So 3 times 1 gives us 3. So that means we have our 5 pi over 12, 3. Let's see, we have a 4 pi over 3 minus a pi over 3, which gives us a 3 pi over 3, which gives us pi. So 3 sine of pi, well, sine of pi is going to give us 0. So we have a 3 times a 0, which is 0. So when we're at 2 pi over 3, we have 0. And again, you kind of start seeing that little pattern forming, right? We have a 0, we have a 3, we have a 0. What do you think is going to come next? A negative 3. What's going to come after that? A 0. But we'll keep doing the work, right? If we continue on with this work, right, this is going to simplify. So we'd have 11 pi over 6, subtract, if we turn our pi over 3 into, what would we have? A 2 pi over 6. So that's going to end up giving us 11 minus 2, 9 pi over 6, which gives us a, what do we got? 3 pi over 2. So 3 sine of 3 pi over 2, which gives us a negative 1. So 3 times a negative 1 gives us that negative 3, which is what we anticipated. So 11 pi over 12, comma, negative 3. And then the last one, let's see what we got. 7 pi over 3, take away pi over 3, which is going to give us a 6 pi over 3, which gives us a 2 pi. So 3 sine of 2 pi gives us 3 times 0, which gives us what we expected, 0. So 7 pi over 6, comma, 0. So we take it and we start graphing some of these pieces, right? We have a phase shift. That means the starting point is at pi over 6 was at 0. When we reached over at our, I don't think they labeled it exactly, and your graphs are probably really, really small. Sorry about that. This was over at a 5 pi over 12, got us to that maximum of 3. When we were at 2 pi over 3, we were back at 0. When we were at, this would have been about the 11 pi over 12. and then back over to that 7 pi over 6. Now they just wanted one complete cycle, so actually there should not be this piece of the graph here, because all I wanted was a starting point and a stopping point. So I had that phase shift. So the period should have only been, which I think was a typo on your notes, the period should have only been from that initial, what was that? Hard to read, pi over 6, up until we got to the 7 pi over 6.